Okay, 3.4b, properties of exponential functions. So the graph of an exponential function is in this form right here. Y equals ab to the x. Okay, so this graph is increasing. So remember, we read from left to right. So we can see that this is going up. Okay, under the circumstance that a is greater than 0. So what this means is no reflection. And b is greater than 1. Okay, so we saw graphs that have a base of greater than 1 go up to the right. Okay, it's decreasing if a is positive again, so no reflection, and decreasing, right? It's going down to the right. Always read from left to right. If we have, I again want to use this loosely, but a fraction. So a number between 0 and 1 as the base. Okay, and then we're going to do the flip of this. So we're actually going to take a look at the two scenarios where there is a reflection. So a is less than 0. So a reflection, and this is a reflection. So if b is greater than 1, what usually happens is we go up to the right, but this time, because there's a reflection, we're going to reflect over the x-axis, and it's now going to look like this. So now we're actually going down. So it's decreasing. Okay, and our b value here, if we're talking about like quote unquote a fraction, we usually have a function that looks like this. Now it's going to reflect over the x-axis, so it's going to look like this. So this is actually, if we read it left to right, this is actually increasing. Okay, so let's just go to domain, range, horizontal asymptote, and y-intercept. So domain is still XER for all of them. Okay, and we kind of talked about the range in the last lesson, but the range, since they're above the asymptote or above the x-axis, y is greater than that horizontal asymptote. And when it's reflected, y is less than the horizontal asymptote. Because there's no shift, the horizontal asymptote is still at y equals 0 in both of these, okay? No shift up or down. And the y-intercept, so now it's going to be this a value. So if we have y equals a b to the x, and we sub in for the x for y-intercept, so y-intercept, if you remember, we sub in x equals 0. This time, if we sub in b to the 0, which cancels to 1, our y-intercept is going to be whatever the stretch value is. Okay, example 1, complete the table of values, and then we're going to sketch the curve f at x equals -3 to the negative x. So if we remember back to transformations of functions, what this means to me is that our base function, so our parent function, is this time 3 to the x. Okay, there's going to be a reflection in the x-axis. There's also going to be a reflection in the y-axis. Okay, if you're given a table of values, you can simply plug in -3 to the -3. So we get -3 to the exponent minus -3. I get -27. Okay, we did the same thing. -3 to the negative of -2. I get -9, -3. Zero is -1. -1/3, negative, I think it's 1/9, and then this is 1/27. Okay, so if I graph this, we get -3, -27, -2, -9, -1, -3, 0, -1, and third and ninth, and that just gets closer and closer. Okay, so looking at this, we can see that we didn't shift up or down, right? Like there's no like plus number here, right? So since there's no plus number here, no shift, our horizontal asymptote is still going to be y equals 0. And now let's just highlight some of the key characteristics. Domain is still XER, it hits every number. Okay, the range, we started with YER such that, so y is less than 0. Because we're talking about this horizontal asymptote, y is going to be every single number here. Right? It's going to be less. It's going to go all the way to negative infinity. It's going to go down forever. Okay? The y-intercept, so there was no stretch on this one, there was just a reflection. So the a value is technically -1, and that's exactly what we have here. 0, -1. There is no x-intercept because there's a horizontal asymptote at y equals 0. Okay. Interval of increase. So if we read from the left to the right, we actually increase the entire time. And it looks to level off here, but it's actually still increasing. It's increasing so slowly, but it's increasing on every single number and never decreasing. Okay, with exponential functions, again, it's going to be one or the other. Horizontal asymptote is that y equals 0. And this time our base, like our base function, is 3 to the x. So our base, we have a base of 3. Okay, example 2, write the equation in the form y equals ab to the x that best describes this graph shown. Okay, so we know that we want it in this form. So if we highlight a couple numbers here, or like a couple coordinates, and just make sure that the coordinates are like super precise, then what we can do is we can find like the ratio, right? So skip first differences, skip second differences. We can find the ratio to actually find what the base is. So for this one, I get 0, 2, right? Because it's right below the 3. I'm not even going to deal with like the negatives here. I get 1, 6. I get 2, perhaps 18. And 3, maybe 54. Okay, so let's do like the actual change in y. So what's 54 divided by 18? We're going to do 18 divided by 6. And then we're going to go 6 divided by 2. And remember, there's always going to be one less box there. Okay, so for all of these, we get 3. So we're going to have a base of 3. Okay, so when we have y equals a b to the x, our base is going to be 3. X is normal. Okay, and our a value is going to be that y-intercept. Okay, so it's actually 2. So we'll bracket. So our equation is y equals 2, 3 to the x. Okay, and then that's the base. This is the a. Okay, example 3, a radioactive sample has a half-life of 3 days. So we know that the base is going to be half, okay, and the time is going to be some time over 3, because it's every 3 days. Okay, this is actually called age. So the half-life, how many half-lives it occurs is T over 3. Okay, initial sample is 200 milligrams. So our A value, our start value is 200. So write a function to relate the amount remaining, A, in milligrams to the time T. So the amount at time T is going to be 200, which is the initial amount, times 1/2 to the T over 3. We can put the bracket there or there, it doesn't matter. Okay, now what we're going to do is we're going to restrict the domain on the function so that the mathematical model fits the situation. Okay, so usually this model would be, okay, so 200 here, and it would go XER, right? However, if we're talking about time, this side here, any negative number is undefined. So therefore, how you restrict is you just put a comma, and then you put T is greater than or equal to 0. Right? Time is greater than or equal to 0.